Good morning, good afternoon, or good evening, wherever you are in the world. Welcome to the latest SOS Intelligence webinar. Do not be alarmed. This is actually I am John, who you've probably seen before, and it is Amir, our CEO and founder, beneath a very special cloak. Amir, thank you so much for being with us today. What are you today?
Well, to crack the captcha, you have to become the captcha. You have to embrace the captcha. You have to wear the captcha. So I am fully committed to this webinar, and I have dressed myself fully in captchas and have a captcha cloak.
Not a Harry Potter invisibility cloak, but a captcha cloak.
It's a captcha cloak, yeah. I mean, I've been called other things, but it's a captcha cloak for now.
And a captcha hoodie.
It is, yeah. I mean, it's actually a genuine captcha hoodie. It's made out of captchas. I love it. It's pretty sick.
Oh my gosh. Wonderful. Well, thank you so much for being here today. We've got an exciting webinar ahead, and those of you who are tuning in right now, thank you for being here. For those of you watching it in the future, because we are recording today's webinar, welcome and thank you for watching this in the future. We've got a terrific lineup of things that we're going to cover. A lot of this is when we've been preparing for this has really, fascinated me in terms of sort of the behind the scenes of what we're doing here at SOS Intelligence. For full candor, I'm not the brains, and I'm not the developer nor the founder. So I'm here in terms of marketing and communication. So it's been really eye-opening to see what actually is happening for cracking captchas for fun and profit. There's a terrible mistake. Okay, so Amir, what are we going to cover today?
Thanks for that introduction, John. And yeah, it's great to see so many people actually watching us live. It is the cracking of what you just said as what I'm doing right now, but no, it's really great to see so many people sign up for this and so many people watching us live, because it's quite a niche thing. And when we kind of pitched this as a webinar, I didn't think anybody would be interested in it because it's such a nerdy, geeky thing, right? But it seems like we've had a really good response to this. So what we will be presenting now over the next sort of 40 minutes or so is a novel approach to captcha cracking that we've kind of developed and designed specifically to target the information sources that we collect from. Cracking captchas isn't something we invented. It's been around for ages, and you can probably read so many PhD thesis papers and all sorts of things around other people doing very similar things to what we're doing. It's just the approach to how we're doing it, I believe, is quite novel. So this is kind of what we're presenting, and hoping to kind of share that with the audience.
Sounds great. Wonderful. So let's have a look at what we're going to cover. Are you okay putting on the next slide? So this is what we're covering today. So we've got a really nice mix of this, some real detailed stuff on some of the topics that we're going to cover, but taking the audience through what we're doing in terms of the cracking techniques, synthetic training data generation, the reverse engineering aspect of it, utilizing machine learning, optimizing the model, which is something we found which has been very important. Something we cover earlier as well, the ethical considerations of this and how we actually use what we're doing, because we are an ethical company, and potentially we could use it in an unethical way and fashion, but obviously we don't do that. And then also bias and variance, and then a couple of case studies in terms of what we've looked at before. So Amir, do you want to sort of take us through take us into what is a captcha?
Yeah, I mean, if I have to explain to somebody what a captcha is and what it's supposed to do, probably on the wrong webinar. But the point of a captcha is to validate the human, right? It's a test to determine whether whatever it is that's interacting with a service is interacting with it as an autonomous thing, or whether it's a human. So it's a automated test, essentially automated Turing test of who is interacting with that particular service. So that's what the captchas set out to do, is to validate that a human is interacting with a website or whatever it might be.
Very good. And it was something I didn't realize. It's not that old in terms of the term. And it's 2003 by Louis Manuel, Nicholas Hopper, and John Langford. But yeah, that was interesting. And the research that I've done, over the last few weeks looking into this, it was actually first invented though back in 1977, but the term itself was coined later than that.
Yeah, I mean, I think, I don't remember when my earliest kind of. I think I probably interacted with captchas before I knew what they were called. And I guess those kind of 2003, 4, 5, 6s, those kind of years were probably at that time, probably because forums became quite popular around that time as well. And I think there was kind of a peak of forum use around about 2006, 2007. And then you've got forum spam and misuse and abuse. And I distinctly remember integrating captchas into forum logins and things like that. So, yeah.
And they've changed over the years, haven't they? We've seen, all manner of different versions of captchas, and probably trying to stay ahead of people trying to crack the captchas.
Yeah, that's right. Yeah, I mean, it's a cat and mouse game. A very simple captcha could be, what's 2 + 2, or something like that, in a web form. And obviously, if the user gets it right, then they're probably not a bot. If the user gets it wrong, then they probably don't know how to add, or they're a bot. So that's, there's always that failure rate, isn't it? Even when you've got a false negative condition. Anyway, I guess moving on to ethics around.
Yes, very important.
Around what we're doing. So I guess just the best way to set this out is to just kind of discuss what the purpose is of why we're cracking captchas, and then to discuss possibly how it could be abused. The whole point of what we're doing is to maintain the automatic information collection through our collection pipelines, and some of the collections are behind captchas, and the purpose of those captchas tend to be for mitigating denial of service attacks rather than mitigating automated collection or validating that the human is reading that text or whatever it might be. So to ensure that we can automate collection and we don't have to have a whole army of people accessing ransomware blogs or whatever the source might be, we go through the trouble of trying to crack that captcha process, trying to crack that validation process, and then we implement that into our pipelines. Now, it's fair to say that if the mitigation mechanism is poorly implemented, that the captchas could be broken, and then that breaking could happen at scale and could be used for denial of service attacks. But our use of this, or our implementation, is definitely not at scale. It's something that we wouldn't scale. It's not something that is required to be scaled, and most of the captchas we've seen have proper rate limiting in place, and it would be quite difficult to, even if you could crack them once, but you couldn't crack them necessarily scale them 100,000 times in 1 second or something like that. That's kind of what I'm trying to explain. But it's entirely possible to bypass them, or any captcha potentially, and use that to interact with a service in an unwanted way. And we've seen that through spam or unwanted bot interaction, kind of like scraping or sniping of like online sales of the PlayStation 5, for example, and things like that. And there's a whole kind of industry around that. And there's a whole actually industry around automated information collection for wholesale stuff, which other companies do, which isn't necessarily our game, but that's kind of how it works. And in terms of, we don't condone unethical or improper use of capture cracking methods.
Absolutely.
Certainly, that's not what we're here to do. But our position, our stance on it is that anything that is client side is fair game. And what I mean by that, and to clarify that, is that anything that's presented to the browser is on my side. It's on my processor. It's in my memory. So I can kind of do whatever I want with it. So what we're not doing is we're not, stuffing things into packets and then trying to overflow a server or do anything, malicious in terms of the third-party system. We can just do whatever we want on our side. So if it's a JavaScript render puzzle or something that we do that. We solve it. If we have to do OCR over text, we do OCR over text. If over an image to get text, if that is on the client side, that's on my machine. So whatever that challenge that's being presented to the user is, as far as I'm concerned, fair game, because it's on the client side. So that's kind of where where we see that position essentially ethically, and the vast majority of the sources that we collect from are cyber criminal run ransomware blogs, which are unethically, their existence is unethical. So to be discussing or to be having to defend as our stance, our ethical stance against who it is that we're breaking the capture of is a bit drawn out. So we'll just leave it at that, basically.
No, it's good. It's good to sort of just make this really clear, because there is an ethical aspect of this. So thank you for that, Amir.
Yeah, great. So I guess that the next step is to really just introduce the problem, and what we mean by when we say advanced capture cracking techniques, and just to kind of paint the picture. So the things that we're dealing with are typically Tor onion services and websites across Tor, which typically have very slow load rates, are sometimes and mostly offline, or sometimes and mostly do not respond to requests in a timely way, or timeout, or there's all sorts of issues with them. So just interacting with them normally as a human is quite a drawn out process at the best of times. And what that means is it makes the process of cracking captures quite difficult in traditional ways. But we kind of expand on how we get around that throughout this webinar. But to start off with, the most important thing to kind of think about and talk about is that a simple problem usually and should always demand a simple solution. So if we're faced with a capture that is fairly simplistic, and a good kind of litmus test of that is if you can throw that capture image into Google Images, and Google Images is automatically recognizing text, and you can kind of like do a text translation from English to English of the capture, and it's kind of saying, hey, these are the letters, these are the characters, then you're probably going to be okay just doing simple OCR. And for the most part, the vast majority of the captures that we've seen and crack, we do so with a very simple process of denoising. So with a Gaussian filter, converting the image, to black and white if required, and then with that filtering, with that Gaussian filtering or desaturation, whatever the process might be required to remove any of the randomly added distortion that is typically added to an image, and that could be like little dots all around randomly placed. For example, like if it was like the night sky and you can see stars, for example, you'd want to be removing those stars so that you can then better do edge detection on the characters that are left over. So that's, really simple starting process is filter the image, filter the noise out, do OCR, and you'll probably get good results. If you get, a error rate of 5%, 0.5% or 1%, that's really quite good enough. And you don't really need to go any better than that with simple captchas. So, start off simply. Don't try to overcomplicate the issue.
That's really good.
So, where the issue kind of comes up, where the problem comes up with in our world, and where we've had to kind of increase the level of solution, increase the complexity of the solution to meet the complexity of the problem. The captcha itself isn't necessarily. The captcha examples that we can showcase here aren't necessarily overly complex. They can be solved fairly easily with machine learning. The issue is machine learning requires a vast data set of training data. And as I've said, these sources tend to be very slow, very difficult to load, and are not necessarily available at the best of times. So how do you gather training data of enough volume to then start training your data model? And the training data that you gather has to also be labeled. So it has to be pre-solved, which is quite a laborious process, and it's a very painful process where you'd have to solve each captcha each time by hand, label and label and label and label until you've lost your mind and ended up wearing a hoodie captcha and a hoodie veil. It's just
we want to try and avoid that.
Yeah, try and avoid that, and it's just not a very useful use of human time.
No.
Absolutely, you could outsource that, but if you could, harvest enough captcha samples to then outsource that to somebody to then actually solve, it's still that's a lot of effort. That's a lot of time. We want to get this thing done, reasonably quickly without much expense and much effort. So we kind of thought about, okay, well, how do you do that? So the approach that we took is not necessarily to worry about the cracking of the captcha or the training of the machine learning model, but it's to build a library of synthetic data, synthetic samples to then feed into that training process. So that's the kind of novel approach. So what we're saying is it's very exhausting to get a real sample set and harvest that sample set of the source captcha. Can we do this another way? Can we reverse engineer the way that captcha is being generated? Okay, so that was like the change and shift in mindset. And we started off by essentially saying, okay, well, how is this captcha being generated? And before anybody kind of gets too ahead of themselves, and certainly for us, it's to look and see, okay, can we fingerprint this captcha? Can we say that this captcha is being generated by this type of library? And a good example of that is InVision PowerBoard, let's say, as a forum software example. InVision PowerBoard will use a set of different captcha library options that you can pick from. Is it any one of those? Because if it is, you can just download InVision PowerBoard, extract the library that's responsible for generating that captcha, run it through some sort of wrapper process, and just get it to spit out solve captchas every time. And there you go. You've got yourself a nice little training set generator. And if it's as easy as that, then problem in quotes solved, and you can move on with your life through that way. But it's not necessarily always going to be that easy. A lot of these captchas are, homebrew. So like the dread capture is very much homebrew type, and the library, or the current library set, is not really obtainable publicly to be able to do that and kind of generate your own real synthetic captchas. So what did we have to do? So we had to basically go through the whole process kind of painstakingly, reverse engineering the process of how that captcha was being generated. And we used a Python image manipulation framework called PIL, and the process was quite iterative, but I'll break it down kind of step by step. So the first process is to identify all of the static elements in that captcha. So that could be the size of the captcha. So is the image size always the same? Are the amount of characters that it's using always the same? Is it always uppercase? Is it sometimes uppercase and lowercase? Is it alphanumeric? Those are kind of things that are static. What's the font? Yeah, so that's quite a big step in the process as well, is identify it and see if you can fingerprint the font, because if you can fingerprint the font, you're part of the way there to reconstructing that captcha in a synthetic way. And a lot of these things are, I appreciate the characters may change, but they are fairly static components to the captcha generation process. And if you can identify all these things, you then have this framework that you can then start off with by actually generating your own versions of that captcha. And as I said, it's a laborious, iterative process, but it's not necessarily going to take days and days. Like, we've done this several times now, and it takes a few hours to get to a point where we've got a very good visually accurate reconstruction. And the point is not to get pixel perfect, or you don't necessarily need to be pixel perfect, but as long as you show that to another human and go, can you tell which one's real and which one's synthetic? And they might not know, or they consistently not know, you're kind of already there at a very, very good level of being able to start training a model. And humans are really good at spotting patterns, especially, like, I don't know if you've ever played those what's missing kind of games where you've got like one image and another image and you're trying to see what's missing.
Oh, yes.
This is literally the best way to explain this process. It's tweaking code to say, okay, we've got a number, we've got this amount of characters, they are scattered in this way. We've got these random lines, and they're always scattered in this way, but randomly. So how do we reproduce that? What's the length of these lines? Is it, take a virtual measuring tape, measure them. What's the thickness? Get the thickness right. Is there a varied randomization to the thickness and the length and the count and all this stuff? And you just iterate through that, taking each one thing at a time, right? And you probe it, and you try it, and you replay it, and you kind of side by side it each time until you get closer and closer and closer to your real data set, your real sample, so that your synthetically generated capture is as close to that kind of real data set sample. So what you end up with is a couple of examples here. So the top one, for those in the game, should be fairly recognizable where that's from, but I'm not going to call anything out. The bottom one should also be fairly recognizable for those in the game, although maybe some of you might, because it's just the way that we're displaying it here is a bit weird, but this is literally what the captcha looks like when you start reverse engineering it. I don't know if anybody can guess off the bat which one's real, which one's synthetic, but I suppose that's the whole point of it, is it could be the left one, it could be the right one. that's kind of like the question to the audience is, could you spot which one you think is, is it right or left as being the synthetically generated one? And the synthetically generated ones have literally been created during using this process that I explained. So this iterative breakdown of how each of the components are built in a way that generates random captchas that are always 100% predictable, because you're generating them, right? You're building them, so you know exactly what the output is.
I've added that as a poll.
Yeah.
So if everybody wants to let us know, that would be helpful. So you should be able to click on the poll tab, and there is an option which is synthetic, right or left. So if we just give it a little bit of time.
Yeah, we'll see what people think.
See what you think.
Yeah.
That would be great.
So
here we go. People are answering.
Right.
So I'll give a few more seconds. So the left is the current choice for synthetic, and right is less popular.
Well, let's see if we get any more votes, because we've got quite a few people on the live watching us live. See if people. What I'll do is I'll make it harder by switching slides as well, and see if you can do it from memory.
We can have a look in a minute. We can go back in a minute.
Yeah. But it's we'll reveal it at the end. I think that's probably better as well. Suspense. That's what the kids do these days, don't they? Yeah. I think there is definitely a clear decision in where people have voted. So yeah, we'll see if you're right. So the next step is to utilize machine learning in the process of then cracking that captcha and getting that captcha solved, because you have a method now of generating a very, very similar, visually similar approximation of the original captcha. You have a good chance of being able to generate a training data set, and I'm talking about 5, 6, 7,000 samples of labeled captchas. So essentially the process is to spit that out through a program that always generates that type of captcha with labels that are assigned to that image, which then you can then pass through to your model, and the model is fairly straightforward. It kind of takes the captcha, it does a bit of filtering, a bit of black and white conversion, and then tries to kind of learn the characters on that image by standard kind of neural network process. So it's not, it's not really necessarily absolutely groundbreaking. We do actually have a question about the Cloudflare captcha. So it depends which one you're asking about. So if you're asking about the joke one where you cut somebody's hand off and you solve it, where you say I'm human, that's very, very solvable. We solve it by very simple training a model to find where it needs to click, and it does that each time very well with a certain amount of randomization and velocity randomization and stuff like that in place. If that's the one you're talking about, it's not like it's basically click here type thing, and I wouldn't even consider that a difficult one to bypass.
Thanks.
So yeah, thanks
for the question, Dinesh.
Yeah, thanks for that question, Dinesh. So the process is then to feed that data set into our model, and to see what happens. What results do we get out of that? And we've got a model that's been trained on a specific type of captcha that's expecting a specific length of characters each time, and we run through about 400 to 500 iterations of that captcha. And once we're done and it's trained successfully, we can then essentially throw it loose at some real samples to try and see what kind of character error rate it gets and see how well we've done. So the first iteration that we got was a character error rate CR of 3.26%, which isn't bad at all. Like that's like if you got a human to solve something like that, you kind of expect that kind of error rate, especially depending on how much attention you were paying. So
yeah,
so
that
that's
seems
great.
pretty good. That seems pretty good for me.
Yeah. So what's the next step then? It's kind of like, well, we've got this character error rate that's not bad. The next step is now you throw your model at the real captcha. So now you've got a model to start solving, and you're now getting that model to generate real captcha samples that are solved. Okay, so you're building up a library now of real solved, accurately solved sample data, because you can, through the process of doing what we're doing, determine whether you've solved something successfully or not solved it successfully. So failed to solve that captcha. So what we now want to do is to start optimizing that model that we have and the training process. So the next step is you then have a mix of real sample data from your source that's been harvested through this first generation model. You then have a on-demand ability to generate synthetically generated captcha data, and you then can start mixing. So you can start mixing that model data in a ratio, which we found a good ratio that works well. And we'll talk about bias and we'll talk about variance, stuffing and overtraining later. But that ratio is important. So you can start feeding in real captcha data and synthetically generated captcha data to then generate the next generation of your model, which we did, and we got a CR of 2.77%, which was slightly but better. So we're heading south in that CR rate percentage, which is really important. So we know we're going the right direction. And if we do this over and over again, and we play with that ratio, we play with that mix, and we try and generate even better synthetic captchas over time, we start getting a better CER, and we start getting a more stable captcha. So what you're seeing there is a graph of CER, so there's the character error rate over time, over iteration cycles. So the light blue jaggedy line is the best model because it starts solving a lot quicker. So it's getting solve rates a lot quicker, getting that initial plateau down faster, and then you've got a best average, best maximum you could expect, then plateau at the bottom sooner, and you've got that darker blue line, which is the worst model, like the first iteration, for example, where it took a lot longer for it to train, and then that plateau started dropping off a lot later, but it drops off at not a bad rate, and then kind of ends up almost at the same position and stability as your second iteration. So it's better, but not that better, and then you get better and better each time.
Yeah.
And you run through these cycles, you end up at a CR of 1.4%, which is really good. Like that's pretty good. We're quite happy with that. Could you go lower? Possibly, but you're starting to get into realms of you're now far better than a human, and could the attacker detect, or could the source detect that? Who knows? So we don't necessarily want to go down the realm of kind of overtraining and overstuffing, which we'll talk about in a second, and what that kind of means and what those terms mean. But that's kind of hopefully a reasonably accessible explanation of the process. So we go with we started off with a target that was fairly inaccessible, fairly difficult to load at the best of times. We are trying to generate a very large sample set of solved captchas for a model to start training on, so that we can then crack that. It's just extremely laborious to solve these things by hand. It would take forever trying to get this to load. It's a real effort, human effort, which is not what we're looking to do. We're always looking for optimization at SOS Intelligence. So we start reverse engineering the way that the captcha is generated to try and get to a point that's an approximation, a visual approximation of the original captcha image, so that we can then start training a first generation model to then mix in real captcha, solved captchas and synthetic into a next third generation, fourth, fifth, and so on, until you get a really good place in terms of your model and you can actually start using it in production. So
I think it's important.
You're desperate to ask something. Sorry, John.
Yeah, no, I just think it's a really key thing for us, and it's a good thing to emphasize, is that one of the whole premises of using SOS Intelligence is the efficiency aspect of things. And yes, we're being efficient with this, but also the usage of SOS Intelligence allows a company and organization to be efficient in terms of what they're doing to monitor cyber threats and reducing business risk. It's if people haven't got the luxury of many people and teams dedicated to this is what we do, is give people that efficiency and give people that ability to get alerts and to understand the threats and the risks that they face online.
Yeah, absolutely. And we can touch on some of those kind of use cases and success stories at the end, and what that means for our customers. So this is the model. This is the best model version that we have. What you're looking at is a exploded diagrammatic view of essentially the visual representation of what the outputted computed model looks like. So we were using TensorFlow with the Onyx runtime accelerator bolted onto that to generate our models, and that's kind of what it looks like when you visualize that model. And all of these little blocks are basically logic gates and different states and things that the model has learned to need to do to solve the captcha. So you're not supposed to see it in detail for a reason, but it's just like to flash it up and show you what that actually looks like in the end. And each version of the captcha solver model looks very slightly different to each other, which is also quite interesting to just kind of dive into and dig into, if that's something that's of interest to you if you're learning about machine learning. So I guess a couple of points on bias and variance, and we kind of touched on it a little bit before, and there are terms that are thrown around in the machine learning world of overstuffing, and if you read one example of what that means to one person, it seems a little bit different to another, and you kind of need a PhD to fully understand it. So I'm not really going to attempt or pretend to fully understand all of that, but what I will try and do is translate it in words that make sense to me and that make sense to me during that learning of machine learning. So what I think it really boils down to is the bias that you may introduce into a model through negative bias or negatively training the model. So this is a issue that we were aware of through the process, where, and some of you on watching us live still may kind of think, may have already thought about this. So if you're getting that first generation to start solving captchas, it's possible that it's only good at solving a certain characteristic or certain set of characters or something. So when you then introduce that solved set, it could potentially be biased towards being able to solve just a specific variance of specific type of captcha, and then the next generation, that bias is kind of exaggerated. So the next generation will predominantly only be able to solve that, and then you just kind of make that problem worse. So it's really important to be aware of that potential negative bias, and that bias or that variance bias overstuffing or overtraining issue can lead into the other side of the spectrum, where you're just generating just far too much variance in your model, in your training data set. So it's possible for us to train a model on two absolutely different types of captchas. So one captcha that does lines through it, one captcha that does wiggly lines or whatever. It's actually possible to train a model that can solve multiple types of captchas. And it's clever enough to do that, right? Because you've trained it on that training data. The risk that you might end up doing is obviously over biasing it one way, where it's difficult for it to determine between noise and signal. So it's being aware of that and trying to tread that line on ensuring that mix is as good as possible and not one way or the other, because you could potentially over bias it one way negatively or positively in another way. So that's kind of just a point on that, and it's something we kind of discuss in the article which is published that coincides with this webinar that we talk about.
Yeah, that's a really good point. If and for those of you who haven't visited the website for a little while, you can find us on sosintel.co.uk, and you can look at the blog, and that's where the article was published earlier today. We're very keen on any feedback that you have. We also publish a regular article every few weeks, so it's worth keeping an eye out, and also the newsletter as well. We would very much welcome you to sign up for the newsletter, and you can do that via the website as well. We have a number of buttons where you can click and drop in your email address and name.
Yeah, so talking about case studies and success, I think you touched that briefly, didn't you, John? What does this actually mean to our customers? Why it's really great for us to talk about this and make ourselves look really clever and capable. What does that actually mean? And I think the reality is it means that we're able to get stuff to customers in a quick method, in a way that's efficient. That doesn't mean that we have to have a team of people pressing F5 and solving captchas, which is a less human cost, which then means a more affordable, cost-effective solution to our customers. And it means that we're also able to adapt quite quickly to changes. So one day a website may not have a captcha, and the next day it may have a captcha. And through this process, and I think something I haven't actually said so far is how long does this take and what's the expected time? And through kind of start to finish, we're talking about 4 to 6 hours. So within a day, it would be reasonable to start off without ever having the captcha cracked to having the captcha cracked with very adverse conditions where it's very difficult to harvest that source. So that's quite a powerful capability to have, and certainly something that we see quite often in the real world, where a source will one day not have a captcha, and then the next day, for whatever reason, because they're being denial of service or whatever it might be, will. But you still need to collect from it, because you need to keep that collection plan running for all your customers. And if we can adapt quickly and make that happen, then that's definitely a tool under our belt, and something that our customers hopefully appreciate.
Yeah, it's access to that information, isn't it? It's the ability to overcome the captcha to get that information, the relevant information to our customers.
Yeah, for sure.
So for those of you who haven't seen a demonstration of SOS Intelligence and the SOS platform, just to be super clear, this is what we do. We are here to give you eyes and ears online in terms of what's happening, and what people are doing in terms of selling or talking about, whether your brand, your organization, email address, or domain. And we alert you when we discover those keywords that are being talked about. And one of the big things we talk about is just reducing the business risk. And I think that's one of the key things that we say to people: business risk insight using cyber threat intelligence. That kind of captures it perfectly, don't you think, Amir? I think we've sort of distilled it down to this at the moment, isn't it? If you don't know, you cannot act.
Yeah, absolutely. And if you know, you can act, and I think that's the most important thing. You can act quicker than if you're told, and somebody removes that agency that you may have on your part. And I think that's quite an important thing that most of our customers appreciate, is being able to be told potentially before someone else may tell them, and remove their agency. And that's quite a deep thought of the deep expression of that, but it's a real thing, because if you can start moving and start processes moving and balls rolling in incident response or PR or regulatory response or whatever it might be, you're already on a foot forward. Then if you're just something and you're like, oh, okay, we had no idea that our information was exposed on the dark web through a ransomware incident that had nothing to do with us, but had something to do with, a third party or something like that. That's very, very real example of a lot of the customers that tell us, hey, thanks for letting us know about that.
And that's hugely powerful, isn't it? Nobody wants to receive that phone call from a journalist or their manager or boss or someone within a company saying, did you know about this? And we've just discovered this, but actually being, one step ahead, which I think is hugely beneficial. And you mentioned a number of key words there, no pun intended, third party risk as well. And we have a lot of our customers who are also not only monitoring their own brand name or particular keywords, but also third party risk is terrible. It's a real thing. It's getting worse. There's so much interwoven data, and people working together. So that's something we're really proud of, is the fact that we emphasize you can use it for third party risk as well. And we have some very people who trust us, which is wonderful. Everybody from people like Vodafone through to Redacted, who we can't talk about, United Trust Bank, and more as well. So I think that's real credit to what Amir has built over these past years. And it goes back to this: if you don't know what's happened or is happening, you can't do anything about it. You are blind to the danger. So I think this is the premise of why we encourage people to get a demonstration, to get in touch with us, so you can speak to Amir or another Amir who's part of our business team. We would be absolutely delighted to show you what the platform can do, how easy it's to set up, how easy it is to set up alerts, and it gives you that peace of mind, whether you're the boss of a company, the founder of a company, the managing director, whether you are in charge of the cybersecurity or whether you're in charge of the IT. It's critical these days to have this ability to keep track of what's happening online and what people potentially are doing with your data, because if you don't know, you can't do anything about it. If you do know, you can reset passwords, you can send out all company bulletins saying that that there is a risk here. So yeah, it is absolutely worth looking into. I think that's sort of the crux of what we tell people to do, isn't it, Amir? Have a conversation with us and we can
Absolutely
explain.
So I think before people drop off, I will put them out of their misery. And I'm so grateful that so many have stayed on right to the end of this webinar, and it's really quite humbling. So I do really appreciate that. And those of you who voted right, you you were wrong. It was left. So the left captcha was synthetically generated. The right one was original, which is great. So yeah, well done, guys. You were right who voted left. So there you go. So that's just kind of shows some of the iterative process that we go through in refining that synthetic generation.
This has been terrific, Amir. Thank you so much for putting this together. Thank you,
thank you,
everybody, for tuning in from around the world, wherever you are, and staying with us this long. One thing I would also encourage you to do is get in touch and let us know what would you like to hear from us on the next webinar. We have got some of our plans ourselves, but it's much better if you tell us what would be of interest. So, don't hesitate to go to the website on the contact and send us an email or get in touch, or even on Twitter as well. You can find us SOS or X, I should say, showing my age. But yeah, SOS Intel, and let us know what you'd like to cover, us to cover in the next webinar. So Amir, thank you so much for your time. Lovely to see you, as always. For everybody tuning in, thank you for your time as well. We really appreciate it. You will receive an email with a recording of this webinar as well. Amir's now putting back on his invisibility stroke capture cloak.
Going back into the capture mode.
Back into capture mode. And thank you again for tuning in, everybody. We will see you next time. And thank you, Amir.
Thanks so much. Bye-bye.